אנחנו מגיעים למושב האחרון והמרתק של הערב הזה. אנחנו מקווים שכל היום כולו יישאר בסימן שנשאר עכשיו המושב הזה, שיש עוד הרבה מה לדון בו. ויש לנו אולי גם עוד כמה נאמני תקשורת המדע שרכשנו במהלך היום. ואני שמחה, גאה, ומאוד מתכבדת, כי היה באמת כבוד ועונג לעבוד איתך, ויהיה גם מחר, להזמין את דוקטור חגי בועז, מרכז אדמונד ספרא, להציג את דבריו ואת האורח הבא.
תודה, אני אדבר באנגלית כי הדובר שלנו מגיע מחוץ לארץ. So we are now at the close of our conference first day, and if to capture the spirit of the conference, it could be that the introduction of science to the public is such a complex task, such an intricate mission. It needs an expertise, it needs a scientist to do that. And in other words, we have now a clear view what the science of science communication is all about. It's about the ways that science is introduced to the public. And the introduction of science to the public could be in the format of an anecdote about an ancient curse on a broken table 2,000 years ago, or the composition of a vaccine, as the two panels before us today have demonstrated. And these are only one side of the coin, the way that communication introduces and presents science to the public. But there's another side. We can ask why at all the science wants to participate in this media, in this carnival. What is their interest? Are they willing at all to participate in building the bridge between science and society? We see, as the president of the university said in his greetings, we see the image of the ivory tower as something which is remote from the society, from the hectic motion of, of newsroom, of something which is on the air and the 1 minute is off the air. Well, in my opinion, there is an importance in bridging this gap between science and society. And this is exactly the topic of our last speaker, the yawning gap, or how to reduce this gap between science and society. And it is my honor to present the last speaker of today's conference, Dr. Jorge Cham. I must admit in shame that I didn't know Dr. Cham work before my colleague to organizing this conference have introduced me to his exciting and amusing works about campus life. Dr. Jorge Cham earned his PhD at mechanical engineering from Stanford University. He worked on robotics, and in one of his famous lectures, The Power of Procrastination, he shows a video of the robots, just, the robots he built running aimlessly, and this is a quote, just like the life of a grad student. And this is one of the motivations that drove him to try and to capture the specific spirit of campus life in his comic strip, PhD, which stands for Piled High and Deeper. And this PhD enterprise earned him an ever-growing number of fans and followers who found his insights on campus life and science not only amusing and wit, but also accurate and sharp. It is a great honor to call to the stage Dr. Jorge Cham, who will talk with us today on closing the science gap.
Hi. So I am not paid by the pharmaceutical companies. which means you can trust every word that I say. No, so I became a cartoonist. I'm a cartoonist now. And to me, being a cartoonist, cartooning, is kind of about taking a blank page and filling it and drawing ideas on it. And so the idea that I want to draw out for you guys here today is this idea of the science gap. And so as I was mentioned, in addition to being a cartoonist, before I was a cartoonist, I have my PhD from Stanford on robotics, and in particular it focused on making these small robots that can run like cockroaches. Yeah. So here's that video that was mentioned before. Yeah, so that is how I felt like, what it felt like to be a PhD student. But that's not the only reason that I showed this video. So the other reason that I showed this video is because it's kind of the only way that anyone will look at my research anymore. Because, you know, it's become very clear to me that by far more popular than the research I spent years working on as part of my actual career, by far more popular has been what I was doing when I should have been doing research, when I was procrastinating, which was to make these comics called Piled Higher and Deeper. And so just to kind of give you a sense of how it all began, it was my first term in graduate school, and I saw this advertisement in the newspaper calling for comics from students. And I remember thinking at the time that, you know, there are a lot of stories about being a graduate student, being a young scientist, being a PhD student, or even just a master's student, that you really, stories that you really don't see anywhere else, you know, in TV shows and movies. It's always about the police, right? And the lawyers. All the dramas on TV are about doctors. I mean, the real doctors. Right? But you never see anything about graduate students. And so I asked myself the question, who is this strange creature called a graduate student? What's going on inside of their complex and complicated psychology? And it turned out apparently it's not that complicated. And I mean that in the sense that, you know, most of the students that I knew, graduate students that I knew, weren't these kind of crazy, eccentric, obsessive types of stereotypes or caricatures that you see in TV shows and movies. Whenever they try to feature a scientist or a researcher or just someone who happens to be smart, they always resort to these caricatures. But most of the people that I knew in academia were really just kind of regular people, you know. We were mostly just trying to survive the experience. And so that's what the comics became about. They became about surviving those meetings with your professors, the begging that you have to do, surviving being a teaching assistant, dealing with annoying students, surviving those late night project sessions or homework, so learning about graduate student etiquette, so for those of you who are not graduate students, if you ever meet a graduate student, never ask them when they're going to graduate or how their research is going. And also kind of about, you know, the sort of the intensity of academia and the oral exams that you often have to do. And then eventually other characters started to appear in the comics, including Cecilia, one of the brave 5 to 10% of women in some fields like physics or engineering or computer science. Then of course we also had the token humanities graduate student, who's always Tejal, who was always protesting something. And then of course we had that guy that's been in every department longer than anyone can remember. The old grizzled graduate student, in this case, Mike Slackenerney. Maybe it hits a little too close to home over here. But yeah, Mike, whose job it is to educate the new students in the way of the PhD. So exactly, money, a social life, a shape, a PhD student needs not such things. Yeah. So that was actually said to me my first year. So I'm not making any of this up. And then, Mike, who, like maybe a lot of the grad students here, you not only have to kind of worry about what your professor thinks of you, but you also kind of have to worry about what your boyfriend or girlfriend or wife thinks of you and when you're going to graduate. And so I kept drawing these comics for the student newspaper there, and I think people kind of connected with them. They liked the comics because not just they couldn't just, because I could maybe just not just identify with the characters, but identify with the situations in the comics. I think people kind of liked it because the subtext of the comics, the kind of underlying theme, was always about asking the real question about graduate school, the big question, which is, why? Why put up with all that suffering and craziness, right? Because I'm pretty sure that no academic goes into academia for the money, unless you're in immunology, perhaps. But no, so back then I got curious and I thought, you know, I wonder how much they pay graduate students, you know, the ones that do work and do research. And I looked up this survey of teaching assistant and research assistants over all these disciplines, over all these schools in the US. And we can take the average of these numbers to get a figure equal to $14,055 as a kind of, you know, general idea of what a grad student gets paid in the US. Per year. Was that a serious question? Oh my God. Per year in US dollars. So yeah, so that's, I mean, it's not bad. You could survive on this, right? Maybe if you eat at McDonald's every day. But to get some perspective to compare this, let's compare it to what you would be earning if you worked at McDonald's. Earning minimum wage in California, that figure turns out to be yes, whew, $15 less. Yeah, I'm loving it. Last year, a couple of years ago, I thought, well, I wonder what that figure is now, because it's been a few years. And so nowadays, because of inflation, if you take that average now in the US, it's more like $18,779, which is, you know, better. Until you compare that figure to how much you would be making, how much the US government will pay you if you file for unemployment, and you tell me you can't find a job, it turns out the US government, for your level of education, will pay you about, which I think proves that it pays more to do nothing than it is to get a PhD. So that didn't quite make a lot of sense, and so what I did next was I kind of took this procrastination to the next level. And I put all these comics in a free website, and on the ones in the newspaper, I put the web address in the bottom right corner. And so slowly over the years, people who would read it there and liked it, they would then tell their friends who knew about, they knew in other universities, and then those people would then tell their friends and their co-workers, and then those people would then tell other people in other universities. And so slowly, kind of like a virus for which there is no vaccine. These comics kind of went out into the world, and so it was actually very interesting, you know, for me as a graduate student to find out that all these stories about graduate school and dealing with your professors and publications and all that wasn't just unique to Stanford University. Oh no, apparently making thousands of people out there weep. But you know, people also thank me for the work that I do. They say, hey, thank you for helping. Thank you for helping me slack off I'm supposed to be working, but instead I just spend days reading your comics. And so this also makes me feel good. I'm pretty sure by now, somewhere in the world, there was probably a graduate student about to make an incredible discovery for humankind. And they were probably in the lab about to make this discovery when suddenly their lab mate goes, "Hey, have you checked out this comic website?" And mankind took a step backwards. Thanks to me. So, you're welcome. There's also, but then I get a third type of comment, which usually goes something like, "Cecilia, that geeky character in your comics, is so hot, can I marry her?" And so this type of comment really disturbs me. Right? Because, first of all, she's an imaginary character in a comic strip. And second of all, she's my imaginary girlfriend. So back off. But then I get a fourth type of comment through the website. It usually goes something like, "You make me feel less alone. Your comic is probably responsible for keeping many of us sane." And so when I get this type of comment, I usually go, "Aw," you know? Makes me think that maybe, just maybe, this isn't just all a huge waste of time. Maybe it's just kind of a medium-sized waste of time. But that's kind of where I found myself a few years ago, and kind of pondering my academic career. I became an instructor and research associate at Caltech after my PhD. And so one day I was sort of kind of looking at my research career and the half-life of it. And I thought, well, I wonder what the traffic for the website, for the comics website looks like. And it looks something like that. And I thought, well, maybe it's time to switch curves. Maybe it's time to switch curves. And so that's what I did. I became, I sort of left academia, and I started doing these comics full time. And, you know, you might be wondering, how does this all relate to the science gap? How does being a cartoonist, what does that have to do with being a roboticist, a robotics researcher? And I can tell you that my mother and father are also very worried about that. But one of the things that did happen was, as this sort of cartoonist who studied robotics and has a PhD was I started traveling all over the world, because, you know, when you're a cartoonist, you don't really need to be in any particular place at any given time. Kind of like a professor. In fact, you don't even have to put clothes on. Kind of like a, never mind. But yeah, so I became kind of a full-time, and then I started to get invitations to go to all these universities and give lectures and say, "Hey, why don't you come here and give us a lecture?" And so I started this speaking tour that over the next many years kind of eventually ended up being over almost like 300 lectures all over the US, all over Europe, and even in other continents. Well, now Israel. Yeah. But even like Australia. So here's a picture of me lecturing some Australian students.
Provide a camel.
Provide the camel. Yes, let's make that happen. Yeah, so and one of the things I started to do as I was traveling and meeting all these people from all over the world was I started to write comics about the people I encountered and the stories they would tell me about their research and what motivated them and how they got into academia and what kind of research that they do. And so I started sort of writing about that as well. I wrote about a long comic about cancer, for example, how lasers work. I interviewed some laser researchers. I interviewed some people who study sustainability and environmental issues. And so I got to meet all these scientists and researchers, and it was really, really interesting to sort of find out all the things that we know as a human species that we've discovered and that we know to be true. But even much more interesting than that has been to discover how much we don't know. How much we still don't know. So for example, here's a list of things you think we know by now, but don't. So for example, did you know that 95% of the universe, we have no idea what it is? So all the atoms in our, I'm really nervous now because there's some high-ranking physicists in the room here. But from what I'm told, okay, just to fact check me. But yeah, I think from what I hear, for the most part, everything you can see, everything you can touch, all the atoms in this room, inside of me, inside of you, they only account for about 5% of the actual known, what we know about in the universe. The rest is things we call dark energy, dark matter, because we don't really know what it is. But yeah, we don't know what it is. But even the stuff that we do know, the sort of 5%. The 5% of the stuff we think we know, we actually don't know all of that, right? Like, for example, how to cure cancer. What causes disease like Alzheimer's? What is gravity? Very basic stuff. There's still so much that we don't know. But that's kind of not the gap that I am talking about, that I want to talk to you guys about. The gap that I'm sort of talking about is basically the gap that separates scientists and researchers from the public. And so that's kind of been the theme of today and tomorrow. I'm sure we'll have a lot to discuss about that. But from my perspective, the way that I noticed that something that a researcher or a scientist does kind of has to go through something like this. So the researcher has to, first of all, publish a long and esoteric paper about it. And then that actually has to get published. And then maybe, just maybe, their university will issue a press release about it if they think it'll be interesting and if they think they'll make a good story for people out there. And then that random press release has to somehow be picked up by some reporter somewhere. And then that reporter has to get it past their editor as a possible news story. And then they have to maybe publish it somewhere. But even then, no publication has that many... that big of an audience, but the way it really reaches the public is if that article or that initial story gets picked up by other media and goes viral, and then maybe eventually it'll reach the public if they're not too busy checking Facebook and all that other stuff. So it's not the most direct way for people to connect with scientists, it's not the most direct way for scientists to disseminate their information. But then something sort of interesting happened, which is that this professor who worked at CERN and who was based out of the University of California at Irvine contacted me and said, hey, I like these comics that you make that explain topics. I think there are a lot of topics in physics, like dark matter, like the Higgs boson, that, need sort of people like you that they can draw cartoons and explain these things very well. I would like to pay you to create these comics about the Higgs boson and about dark matter. And I said, what? You want to pay me? Let's do it. And so I went and I interviewed him at the university, and then eventually we met up in Geneva, and he gave me a tour of CERN, and we didn't touch anything, I promise. I interviewed him there, and just to keep my notes straight, I brought a camera and I recorded him and the interview. And then as I was making the comics, I sort of noticed that online a lot of people were starting to experiment making these science videos, mixing live action and drawings and things like that. So I thought, hey, why don't we experiment as well? And so I took this recording of him that I edited, and I recorded myself drawing the comics, and we created this video about the Higgs boson, which I can play a little bit for you here, maybe about 3 or 4 minutes of it.
Ever since the accelerator turned on, like a year ago, it's been really totally crazy here. Because everybody comes and sends their students and...
Oops.
It's the center of the world.
Oops. Let's find it. It's here. You'll play here.
Like what's going to pop out of it? Who knows what, right? This is when, last time we talked about surprises, this is when the surprises might happen. So any day could be the day that changed the world. The LHC is it's really all about discovery and exploration. We're looking for different kinds of things, new crazy kinds of things. I mean, to make up everyday matter, you only need the electron, the up quark, and the down quark. Because with the up quark and the down quark, you can make a proton, or you can make a neutron, right? Electrons and protons and neutrons, you can make any atom. So you only need these three. But there's, how many particles are there we've discovered? 12? Why do we have them? I don't know. How many are there? 100? A million? Only 12? We don't know. We're like looking at the tip of the iceberg here and wondering, is there a huge iceberg under the water, or is this it? And what does it mean in either way, right? We're looking for patterns. It's just like the periodic table. You take all the elements and you organize them by their characteristics, and they fall into categories. And these guys over here tend to behave one way, these guys tend to behave another way. Why? Because there's a fundamental underlying structure. And now we know it's just electron orbitals around nuclei. So we have a periodic table of the fundamental particles, and like the periodic table, we've been putting it together and trying to organize it by the characteristics of the particles. And it has some interesting features. It has patterns which suggest there must be some sort of underlying structure that we don't understand, but we haven't seen it yet. There's 6 quarks: up, down, charm, strange, top, bottom. These guys we call leptons. These are just names. There's electron, muon, tau, and these guys interact with each other. These two interact with each other. These two interact with each other. Same way, these guys are paired. There's all these pairings. Is there more here? We don't know. What's the source of the patterns that we see in this table? We don't know. They're trying to figure out clues by figuring out what other kind of particles also exist. Like, what is out there? The thing is...
Should I keep playing, or we're good? Okay. What's that? We're good. Okay, so yeah, so that was pretty cool. So I posted that online on my website, and so it did pretty well. But then when the Higgs announcement was made earlier this year, the video really went viral because let's see, let's get back to the slideshow. It got picked up by all these different media. So New York Times, CBS News, all these websites picked it up and hailed it as, you know, one of the best explanations. Like, if you're really confused about the Higgs boson, here's an animated cartoon that at least, you know, attempts to explain what it is. Although I'm being told that it's not 100% accurate to the utmost level, but you know, it attempted to do that and explained it in a way that it made it accessible to a lot of people. So that was pretty cool. You know, imagine all these media outlets on this huge news story of the year, and the best explanation of what was going on came from an actual scientist himself, who didn't wait for the press release, for the paper, for the reporter to come calling. He just took the initiative. He contacted somebody who thought he could work with, and produced this thing, and we put it out there on the web. So it came from his own initiative. So that's pretty cool. But you know, I think there's also sort of another different kind of gap between scientists and the public, which is a gap in how the public perceives scientists and researchers. So I talked a little bit about the comics that I do and that I make, and you know, they're they're popular for the internet. You know, there's about 7 million people who visit the website and read the comics every year. But you know, outside of academia, or even within academia sometimes, not everyone has heard about it. And in fact, if you sort of ask someone outside of academia in the public what they think of when you mention a scientist or a researcher, most likely it's probably something like this. This is from Revenge of the Nerds, 1984. And you're probably thinking, 1984, Jorge, come on, that was like, how much, 30 years ago? Surely things have changed now, right? Perceptions about scientists and researchers are totally different now. Totally different. That's from the one on the right is a picture of basically one of the most popular TV comedies on American television and Canadian, I think. Do you guys get it here as well, or legally, like on the internet, perhaps? But yeah, The Big Bang Theory. It's a very popular show. I don't have anything personal against it. You know, I enjoy it when I watch it, but it is something that sometimes sort of finds humor in these sort of scientists and researcher stereotypes. If you sort of look at all the characters in this TV show, you know, all the smart researchers are dorky guys with no social interaction skills, and you know, the normal, happy, perky person is this blonde woman who wears tight clothes. And so again, I don't have anything against the show, but I do sometimes wonder sort of what these stereotypes and what these caricatures, what kind of effect they can have on society. Because one of the things that I do, in addition to drawing cartoons, is I also sometimes volunteer at this small middle school in East Los Angeles. And if you're not familiar, East Los Angeles is sort of one of the struggling areas in Los Angeles. It's mostly minorities, and you know, half of these kids will never even graduate from high school. About 80% of them live below the poverty line. Here's some images of these kids. If I can get this to play. It's not going to play very well. But yeah, I sometimes volunteer at this school, and I sort of think about, you know, maybe in this classroom is the next genius who's going to save humanity, right? Or maybe the next Marie Curie or the next Darwin is in one of these classrooms. You never know. But how are these kids really going to sort of see themselves as potential scientists or researchers? How are they going to think of themselves as being able to do that if all they see when they turn on the television are these stereotypes of what scientists and researchers are supposed to look like, or what you don't want to be when you grow up? And so I guess the main idea I'm trying to communicate to you guys here today is that, you know, we need to work a little bit more to close this gap both in communication and perception between scientists, researchers, and the public, so that, you know, more and more of us can be engaged in this search for answers and to reduce the number of things that we don't know, and maybe even find new blank pages on which to fill with ideas. So thank you very much.
Okay, so thank you. If there are any questions to...
Oh no!
Don't worry about it. I just want to know what percentage of your time in your PhD you spent on doing comics.
What percentage?
Yes.
You know, that's a funny question.
You wouldn't wonder why your age.
Well, actually, I've been told age 6 is actually not bad for a young guy. But you know, what happened during graduate school was that I would procrastinate doing research by drawing these comics, and then I would procrastinate doing the comics by doing research. So actually, I had a pretty good completion time. Yeah, in fact, I even interviewed at MIT and all that, but you know, eventually this is kind of where things led me. What am I working on now? You mean, how's my research? Did you learn nothing from this? What am I doing? So I draw the comics full time. So I draw the comics, I run the business, I collaborate with scientists to make these videos. Yeah. I travel to exciting and awesome places. That's a very good question. The question is, how do we improve how the public perceives scientists and researchers? You know, I think that as a science, are you a graduate student, I imagine, or yeah, I think that I think just going out there and interacting with people, I think that's the best thing that you can do as a scientist yourself. Yeah, find a school that you can maybe give help out in or produce things. Yeah, that's a very good question. I think if I had the answer to that, we wouldn't be here today. Yeah.
Still draw comics for PhD students.
Yeah.
And you're not a PhD student. I read them every week. I belong to the false category. This keeps me going. And I just wonder how you manage to capture the essence of being a PhD student, even though you made it and graduated. There's beginning to be a gap between yourself and
PhD gap.
The PhD gap. That's another lecture. Do we have time for it? No, that's actually one of the most common questions I get. And, you know, my first answer is that, you know, if I draw a comic strip for every day that I was in grad school and as a research associate, I'm only like halfway through after all these years. But the second answer I usually give is that, you know, I sort of realized very early that these comics, that this website was really more, it was more than just about me and what I went through and my experiences. It's really sort of about you guys, right? Everyone who's sort of going through it and went through it. And so right now, I've always, from the beginning, just kind of saw myself as the guy who draws the comic. But a lot of the ideas now come from the audience, from events like this. People come up to me and they tell me their fun stories. Yeah.
Given the trend that you're showing to close the gap between science and the public and just go online with your research and your findings, how close are we from judging science in peer-reviewed newspapers to a huge like contest?
How far are we from?
Judging science by scientists to having someone publish their research and get likes in Facebooks and Twitter retweets and go to their department heads and say, but this article has 10,000 shares and 500 likes and so on and so forth. Twittering.
Yeah, no, I have a comic somewhere. I drew a comic about the topics guaranteed to get you a lot of media attention. So one, robots. I think newspapers are required to write a robot story at least once a year or once every couple of months. A false robot. Second, you should do research on how chocolate is actually good for you. That always gets or coffee, yeah. And third, you should do research on some kind of big machine that maybe when you turn it on might destroy the world. That will.
Is this a good trend?
Well, you know, I think the institution of academia is still pretty strong. Like, I don't think, you know, when people judge what gets published in journals, sort of pay attention to that sort of. Thankfully, currently, I don't think that's true. I mean, I've been out of it a little bit, but would you say that's different?
I've been out of it also, but it's not different within just the university, but it's getting different outside.
Okay, yeah, last question. Yeah. Say again? Oh, a recipe for taking something serious and turning it into turning it into something funny. Well, you mean like how to make something funny? Like how to do comedy? Oh, about science. You know, humor is kind of a difficult thing, but you know, I always sort of follow what the author of Calvin and Hobbes. Are you guys familiar with the famous comic strip called Calvin and Hobbes? He said in one of his books, he said, surprise is the essence of humor. Surprise is the essence of humor, and nothing is more surprising than the truth. So I think, you know, if you can find some sort of truth in whatever it is that you're doing that is surprising, I think you have a good key to finding humor there.
With this beautiful תודה לכולכם שהייתם איתנו, תודה למארגנים, ונשמח לראות אתכם מחר בסדנאות.